Good morning student. In this lecture we are going to discuss about circuit problem. Our problem is like this. Initial current through inductor is 3 ampere is given. This is the most important point here to be noted that initial current through inductor is 3 ampere. So using Laplace transform, determine the current IT when t is greater than equal to 0 and also draw the as domain representation of the circuit. So to solve this question we have to use KVL. Okay, so first of all we should know what is KVL. Okay, so KVL says that the algebraic sum of all the voltages in any closed loop in the circuit is equal to 0. The algebraic sum of all the voltages across a resistor, across inductor and across battery, the algebraic sum of all the voltages in any closed loop in a circuit is equal to 0. Around any closed loop in a circuit is equal to 0. If we take negative 1 minus 48 volt and goes to this positive terminal, means our IT voltage across a resistor, and goes to this side positive terminal, L di by dt is the potential difference across inductor is equal to 0. Now this minus 48 goes to this side. The remaining term is like this, RIT plus L di by dt is equal to 48. Okay. Now to solve this equation we have to use Laplace transform. So on taking Laplace transform, RIT means RIS, we directly write IT into IS because IT is simple, there is no initial condition in resistor, but for inductor there is an initial condition is given. So the L is constant and di by dt can be written as times of IS minus IL at 0 positive, means this is the initial condition, that's why we can subtract from that part. Okay, the Laplace transform of 1 is equal to 1 by s, 48 by s. Now multiply L inside, LS IS minus L IL at 0 plus equal to 48 by s RIS. Put the value of R, L and IL at 0 positive. Put the value of L is equal to 1 Henry, R is 4 ohm and IL at 0 positive is equal to 3 ampere. Substitute the value of R, L and IL at 0 plus here, then we get equation like this. Now move further, 4 times of IS, S times of IS minus 3 is equal to 48 by S. Now take IS common from here and here, the remaining term is 4 by IS and minus 3 goes to this side. Now take LCM, and then we get 48 plus 3s by S. Now this term 4 plus s goes to denominator of that function. We get I is equal to 3s plus 48 divided by s times bracket में 4 plus s. And now I is equal to 3s plus 48 divided by s bracket में s plus 4. To solve this function we have to use partial fraction a upon s plus v upon s plus 4. At this stage we have two options. The first option is conventional method, it is a lengthy method, and the second method is by residue method. So in my opinion to you, this is you opt residue method because it is a easy method. Okay, so a is equal to s times of is function, where is function 0, s is equal to 0. Okay, that's why we take s times of is is this one, numerator and denominator cancel out s, the remaining term is 3s plus 48 divided by s plus 4. Where is function 0, s is equal to 0, so put the value of 0 here and we get 12. Similarly for v, where is function 0, s is equal to minus 4, that's why we take s plus 4 times of is, so that numerator and denominator cancel out, s plus 4, remaining term is this, where is function 0, s is equal to minus 4, put the value of minus 4 here, then we get minus 9. Now on putting the value of a and v in above equation first, then we get like this, 12 by s plus minus 9 divided by s plus 4. On taking inverse Laplace transform we get Laplace transform of 1 is equal to 1 by s. So The inverse Laplace transform 1 by s is equal to 1, and 1 upon s plus 4 is equal to e raised to the power minus 40. So this is the amount of current flows in this circuit from this source, okay, at t is equal to 0 when the circuit is closed. Okay, and now also draw the S domain representation of the circuit. So basically Laplace transform doesn't impact on resistor. It is same as previous one in time domain representation. Okay, what change in inductance due to the initial current? Okay, means inductor can be written as L times of S minus this voltage drop, L times of IL at 0 positive. This voltage drop subtracted from this voltage drop because of initial current. There is a representation to write inductor in S domain. Okay, put the value of L 1 S, put the value of L and IL at 0 plus 3. Okay, so this is the overall S domain representation of that circuit. Okay, so thank you.